All right, class. Today is Tuesday, April 14th. Welcome back for spring break. I've already sent you some announcements, so you kind of know where we are. Just a reminder, you have an exam number 3 this Thursday, so check your announcements if you have forgotten all the requirements for that. And in this little video, we're going to just do some practice review of our quantum numbers and letters, which we learned before spring break. That is on your exam 3. And so we're going to do some examples, go through, make sure we really understand them, because this is something that you're going to need to continue to use throughout the rest of the semester, and also all the way through organic chemistry. So just taking a peek in our packet, it's our light energy packet where we encountered this. We went over all these different quantum numbers. N, which was our energy shell, outside of the nucleus where electrons can be found. L, which described the shape of the orbital, and there's different types of orbitals within each energy shell outside the nucleus. M sub L described the orientation of each of those orbitals and also told us how many of each orbital there actually is, and M sub S actually was unique to an electron, the spin of an electron, and there were only 2 ways they could spin. So make sure you go back through that video. That's really important, where we deduced and talked all about this. Okay, so we covered quite a lot in here. All righty. So we are going to do some examples and then also look at our periodic table. So looking at different quantum number sets. So for example, let's say we were given these values. N is equal to 3. Okay. L is equal to 0 and 1, okay? And let's say that's all they gave us, okay? Now they want to know, what does this actually mean? So we need to understand what it is we're talking about. So this, again, is telling us we're in the 3rd energy shell outside the nucleus. This is the 3rd level outside the nucleus. Okay? Now remember, L tells us the shape of the orbital, so you do have to know what the numbers represent. So we're in level 3. This is talking about an S-shaped orbital, okay? And this is talking about a P-shaped orbital. So these are both actually found on level 3. Now, some people go, well, what about the D orbitals that are in level 3? Well, sure. If we think about the values for L, they can be 0, 1, and 2. Okay, so for n equals 3, these are our possible values. Okay. But if they gave us this right here, they're just wanting us to talk about the electrons that can be found in the S-shaped spherical orbital or our P-shaped, kind of like 2 balloons together, those types of orbitals. So another good question is, so again, if we're thinking about this, what we're talking about, let me write that down. So we're talking about a 3s orbital and our 3p orbitals. Okay? And again, this 3 is telling us your 3rd level outside the nucleus. Okay? Now for this example, we're not talking about the D-shaped orbitals. So here's another question for you. How many electrons can possibly fit? Okay? Or how many electrons can possibly be found in this quantum number set? N equals 3, L equals 0, and 1. Okay, so that means we've got to know how many orbitals exist for each of our shapes. Okay, so again, this was our S and this was our P. So how many types of S orbitals are there? Well, remember when we did our M sub L values, we only have 1 type of S orbital. But when we did our M sub L values for our P's, we found out that there are actually 3 different values. So we have 3 types of P orbitals. Okay? So if we can imagine using these boxes to indicate how many electrons we have, well, we talked about that exclusion principle, that Pauli exclusion principle of how many electrons can fit into an orbital. Well, I could fit in 1 and then 2 here. Okay? And remember, can I put a third one in there? Nope, because it would repel. So opposite spins attract. Now, since there are 3 p orbitals, I'm going to draw 3 boxes here. Okay? And those will represent my px, my py, and my pz orbitals. Okay? Now, if I could imagine how many electrons could possibly fit, again, it doesn't mean there are that many, just how many could fit, we would have 1, 2, 3, 4, 5, 6. So when we're looking at this question, how many electrons can possibly fit into this quantum number set, we're talking about 2 and 6. This is a total of 8 electrons. So let's try another one. Let me flip this over. Alrighty, so let's say we are in level 4. Let's go way outside that nucleus. Okay. Now remember, this is just our energy shell, like the floor of a hotel outside the nucleus. And then let's say they said L was, let's say 1 and 2. Okay, I'm just giving you some of the L values, not all of them, because we just want to look in certain rooms. Let's say you're on a floor of a hotel. We don't want to check every floor. We just want to walk into a couple of the rooms. And then let's say our M sub L value was equal to, actually I don't want to do M sub L. Thinking off the top of my head, let's do M sub S is equal to a positive 1/2. Okay, so just talking about one particular spin of an electron. Okay, so what do these things mean? Well, we are in the 4th level outside the nucleus. Okay, so that's the floor of our hotel. And then what do these L values mean? Remember, in level 4, sorry, look at my nail polish. If you check out our videos from the beginning of when we started all this online business, I had a lovely manicure. So sad, and now it is looking like this, but I have a date with a 6.5-year-old, soon to be 7, this afternoon, so you might see something interesting in our next video. But anyways, so in level 4, we have 4 orbitals. There's an S, there's a P, there's a D, and there's an F. So these were patterns that we looked at in our previous video. Now we were just given 2 values here. So again, our L's could be 0, 1, 2, and 3. But notice they just want to talk about these 2 right there. So we're not walking into every room, we're just looking into a few of them. Okay, so this is a P-shaped orbital, and this is our D-shaped orbitals. Okay, now we do need to know the question, how many of each orbital are there? Well, we know that there are 3 p orbitals, and how many Ds are there? There are 5 d orbitals. Okay, so 5 different rooms for our d orbitals and 3 different rooms for our p orbitals. So before we talk about the spin, let's draw out those rooms. So I'm going to do 3 boxes for my p's. Again, this is my px, my py, my pz, my different orientations. Okay, and then let's draw 5 boxes for our d's, and you can get all those orientations in your textbook, like the dxy, the dz squared. Okay, so these are all of our d's. Okay, so the question is, how many electrons can fit in those rooms? Remember, we can only put 2 electrons per room, or else the third one would repel. So let's do all of our up spins first. Okay, and then all of our down spins I'll do in blue. Okay. Now, same thing for our Ds. We'll do all of our up spins. And then all of our down spins in blue. Okay. So if we look, our total possible electrons is, let's see, we've got 6 plus 10 are 16 electrons. But that's not the end of the question. Okay, so I've got to say, but they said we have an m sub s value equal to positive 1/2. They didn't not give an m sub s, meaning we could just think about all 16 electrons. They said we only want to look at the electrons that have the up spin. Okay, and I actually drew my up spin in green, so let me do this in green. Okay, so we're only talking about half of our electrons. 1, 2, 3, 4, 5, 6, 7, 8. So the possible electrons that fit this are N equals 4, L equals 1 and 2, and m sub s equals positive 1/2. All of this is talking about 8 electrons. Okay. Alrighty, so one more example for this video, and then I'm going to upload it to you so you can practice your quantum numbers. Let's say, is this possible? Let's say we're in level 2, and they said our L value was 2, and then they go, is this possible? Okay, the answer is no, because how do we find our values for L? L is found by taking everything starting from 0 to n minus 1. Okay, so if I put my 2 here, my L values can only ever be 0 and 1. There is no d orbital in level 2. Okay, so this is wrong. There is no d orbital in level 2. Okay, so this is not an allowed quantum set. It doesn't exist. Okay, so just a quick little recap. In level 1, we have an s orbital. Okay. In level 2, we have s's and p's. In level 3, we have s's, p's, and d's. And that pattern continues. In level 4, we have 4 types, S, P, D, and F. And that pattern would continue. In level 20, there would be 20 types of orbitals. Now, how many of each orbital exists? Well, remember, there's only one type of s orbital. Okay. Our p's, there's a px, a py, and a pz, so there's 3 types. So 3 possible rooms there. Our d's, there are 5. Okay, and our f's, there are 7. So notice that pattern, 1, 3, 5, 7. So on level 1, there is just one room that you could book for your stay in an Electron hotel. Okay, we've got 1 orbital total. Okay, but on level 2, we've got 1 and 3, we have 4 orbitals total. Okay, and then you could keep counting up. What's in level 3? We have 1 and 3, that's 4. 4 and 5, we've got 9 total rooms on level 3. And then on level 4, we've got 9 and 7, we've got 16 total rooms. I'm just going to write etc. because you could do the counting up yourself. So we have all of those patterns there. All right, so we're going to stop there. Make sure you practice those quantum numbers and letters. And in our next video, we will be covering electronic configurations, examining our periodic table, and telling exactly for whatever particular element we have, right? So we'll be like, oh, okay, where are all the electrons of carbon? We're going to map it all out into an electronic configuration, an electron's address, where they all live, what floor, what shape room, what orientation of room, and how many electrons possible. So we will be doing all of that in our next video. Talk to you guys soon. Bye-bye.